Hi, I'm Dr. Heather Bedle, and today I will be showing some of my recent research that I've been performing with sociologist Dr. Christopher Garneau at the University of Oklahoma. As a data scientist, I've spent years dealing with big data sets, and about a year ago, I was motivated to try and understand if we could use some of my AI methods to get a better understanding of society's climate problems and solutions. This delves into the question of if we can use these AI methods to understand what drives people to reduce their personal water usage. My hope for this work is that if we can understand factors or similarities among people who try to save water, perhaps this can lead to new policies to reduce water usage. What I will present today is just one slice of the research. I will explain our AI method and then demonstrate what it reveals about what water reducing factors in Oklahoma and give you a peek at some of the national data. In my role as an earth scientist, I often interact with people thinking that the way their mind works is a mystery or a black box to me. So as a machine learning enthusiast, I thought it could be interesting to apply the method I use to understand what is going on in the black box of machine learning algorithms for geological purposes to social survey data. Here I'll be using a method called SHAP, a method which is based on economic game theory from the 1950s, which uses a leave one out strategy to understand the relative importance of a single feature to the outcome. The contribution of each variable is reported as its SHAP value. Let me try to explain how I apply this. In this case, with the figure on the lower left, we have our survey data with a myriad of demographics such as politics, experiences with temperature, a person's education, and we ask the individual their opinion on the risk of climate change to humans. What we get out of the survey is the individual's opinion, as well as the opinion of the global survey population. But with explainable AI methods, we could try to look deeper into the data and understand the relative importance of each of these variables. So using SHAP, shown on the figure on the right, we can look at each individual, such as this one here, and note that their identification as a liberal or Democrat leads to an increase in their concern with climate change, kind of plotted in a reddish color, while their lack of experience with extreme weather and their education level reduces their concern, plotted in the bluer colors that shift it more towards the left. So once we calculate that SHAP value for each individual, like I just showed, we can now do it in a global manner, so with all the survey data. And so in this example, we're looking at the belief in the certainty of climate risk. Is climate change going to be risky to humans? On the left, we have people who identify as liberals, and on the right, conservatives. This figure ranks each variable in terms of its relative importance. So for both groups, a high egalitarian worldview is the most important feature in being very certain that climate change is a risk to humans. After that, as we go down the list, the variable's importance starts to lessen. So for conservatives on the right-hand side, note that the second feature demonstrates that those who experience a high frequency of weather events are most concerned about the risk of climate change to humans. So we can dig into this specific relationship using what we call interaction plots. Here I've got an interaction plot for the SHAP analysis between all the different variables, where the darker colors relate to strong relationships between the variables. And we could take any specific pair and look into that relationship in a little more detail. So next I'll show a partial dependence plot for the extreme temperatures and weather event frequency, highlighting by this little red box. So on the plot on the right, we can look at the effect of extreme temperatures for Republican conservatives. So I've pulled out that subpopulation. And what we see are that for those who think extreme temperatures are getting worse, so they have a horizontal value of 3, the reddish color bar, the reddish colors from the color bar, shows us that they get even more concerned if they've noticed an increase in the frequency of severe weather events. So hopefully now you're a little bit intrigued on how SHAP can help us extract relationships in our data sets. So let's get to the good stuff. How can SHAP help us understand the commonalities of Oklahomans that try to conserve water in their personal households? For this, I'm using the Oklahoma Mesoscale Integrated Sociographic Network data, specifically from a survey taken in the late summer 2018. So first, let's set the scene and go back in time 4 years to September of 2018, highlighted by that pink arrow, when Oklahomans were taking the survey. As we look at the state drought data, we can note that the previous 3 years to the survey were quite wet, kind of highlighted in that pink box with a lot of blue. But more severe droughts were not too far in the past. This survey that I'm using asked respondents about if they had tried to reduce water usage at home using a variety of possible steps, from washing their cars less to repairing leaks or installing low-flow shower heads or toilets. The total number of steps taken were summed by me for each individual to quantify their water-reducing behaviors. This is, in a sense, the variable or our outcome that we're going to be trying to understand with SHAP. So total number of water reducing behaviors in the summer of 2018 is what SHAP will help us identify the important factors for. So while SHAP can handle hundreds of variables, we just don't want to throw them all in there haphazardly. SHAP is just an algorithm, so we need to be careful to keep our methods aligned in theory. We chose variables that previous research demonstrates are closely associated to environmental concern. These include factors such as demographics, political and religious beliefs and behaviors, social behaviors, and even some more psychological variables that link a person's belief system to ecological systems, such as their cultural worldviews. Most importantly, we include variables related to an individual's experience to weather and the natural world. And of course, with the chart on the right, we check for multicollinearity between variables. So now we can finally examine our SHAP results. And here are the top 20 variables in order of relative importance. On the horizontal axis, we have an increasing scale for those who are taking more total water reducing actions at home. And then on the right side of the axis, down vertically, those are the factors that are most important in taking more actions. Looking at the top few, we notice that those experiencing more types of severe weather events recently, from hail to wind to tornadoes, as shown in the redder colors, are taking more actions to reduce water usage. Third down, we note that liberal-leaning respondents are also taking more actions, and that income and age are also important. But note by the color scale that income and age have a nonlinear relationship. So let's dig into this income variable, which is the second most important feature for reducing water usage. First, let's look at an interaction plot, which shows the statistical interactions between two variables. I'll highlight the income variable in purple. What I notice here is that income seems to have a high SHAP interaction with weather event experiences, age, and gender. We could examine each of these pairs by plotting both variables and their SHAP value together. On the horizontal axis, the number of weather events is the number of weather events, and the respondent experienced is plotted. The vertical axis shows the SHAP value for each of those weather event experienced values. Above the blue dotted line at 0, that represents a greater number of water reducing behaviors. So the overall trend is that experiencing more weather events results in a greater number of weather reducing behaviors. But if we look at income, which is presented in color, we note that the overall, lower incomes, those in dark blue, take less actions for lower amounts of weather events and more actions for greater amounts. Middle incomes, plotted in green, are more zero-centric with a lower slope, and high incomes with that brownish orange color are between those two. Next, let's look at the effect of income with gender and age. With a SHAP interaction chart on gender on the left-hand side, we note that data reveals that lower income males are taking a few steps, but most females are reducing their water behavior, with the exception of lower income females noted in kind of those darker blues and purples. Regarding age on the right-hand side, notice that the young adults tend to take more actions than those in middle age, and that the trend in water-saving behaviors does increase with age. But I will note that if we look at income, so the colors of the dots, the higher incomes tend to have a lower slope than the middle and low incomes, suggesting that those with more middle range incomes are more susceptible to changing their water behaviors as they age. I'd like to spend a few minutes on the national survey data collected at the same time in 2018 and asking the same questions to about 1,800 people all over the US. Looking at the SHAP results, again, weather events are the most important features, and unsurprisingly, the region of the country people live in is the second most important feature. As I only have a couple of minutes left, I want to delve into these top two factors, looking at subpopulations also separated by their political leaning and their ideology. So the US Census regions that this survey's divided people into, we have Region 1 is the Northeast of the US, Region 2 is the Midwest, Region 3 is the South, and Region 4 are the Western states. I've additionally divided them into subgroups, as you can see in the upper chart, with Democrats and Republicans on the left-hand side, liberals and purples, conservatives in green. So that would be their partisan and ideological leanings. So starting on the left in blue, we note that Democrats in the Northeast, so that's Region 1, and the Midwest, Region 2, take fewer water-reducing actions. But those in the West are taking quite a few more water-reducing actions, which kind of makes sense if we think about the weather patterns around the US. Republicans in red in that second chart hover more in the middle, and region doesn't appear to be a very strong factor for Republicans taking water-reducing behaviors. Both the liberals in purple and the conservatives in green have similar regional trends to the Democrats. So next, we will look at the regional trends more, bringing in that important variable of weather events experienced. As we note here, experiential events are very significant for inducing behavior changes in water consumption across all political and ideological beliefs. Interestingly, we note that these experiential effects are much stronger among Republicans and conservatives than they are for Democrats and liberals. And for the most part, the effect is strongest for those living in the West, as colored in the reddish color now, regions in the color bar. And we suspect that this is related to the psychological theory referred to as construal theory, which states that as events of any kind, not just weather events, happen to a person, so as that person experiences things and those events become less abstract in their mind and more concrete as they're happening, which may be happening in these cases, both the Oklahoma and national data sets, we found that experiencing more extreme weather events, perhaps people are becoming more in tune to issues in the natural world where water usage, with the occurrence of droughts and less rainfall, being one of those events. So while there are many more interesting aspects to explore in this survey with the motivations of individuals and their water-saving behaviors, I just want to conclude here and summarize with the hope that I've demonstrated how explainable AI methods can be employed to reveal theory-based nonlinear relationships in survey data. I will also note for any statisticians or social scientists out there that we run linear multinomial regressions or binomial regressions to try and back up and validate these SHAP results, as this is a new way to look at survey data. I also want to highlight that throughout this survey, as well as some of the other ones that I've looked at with this method with Chris, that as we investigate the societal implications of climate change, experiential factors tend to be the most important factors in attitudes and behaviors, suggesting that this increasing awareness of an individual's link with the natural world may be a really critical factor in how we approach climate mitigation solutions, from droughts to disasters responses, and even new technologies like carbon capture type technologies to mitigate carbon issues. So with that, I want to conclude and thank you all very much for your time and listening to this. You can feel free to contact me via email or I can take any questions.